because of where carbon sits in the periodic table, carbon can do things that no other element can do. So, for example, carbon can bind to 4 other atoms, and this is an example where it's binding to 4 hydrogen atoms, and this is methane. Or it can bind to 3 other atoms, and this is an example where it's binding to 2 hydrogens and an oxygen, and this is something called formaldehyde. Or it can bind to 2 other atoms, in this case nitrogen and hydrogen, to create something called hydrogen cyanide. No other element has this amount of versatility. And these are little small molecules, but actually these sort of structures can be expanded in space. So here is carbon binding to 4 other carbon atoms, and that's diamond. Or carbon binding to 3 other atoms, but in a sort of in a plane, and these sort of planes stacked on top of each other, that's graphite. Or as Sylvia said, it can bind in a line, and you get these things called polymers. Now what we're interested in is the middle one, graphite. So graphite is made of layers of carbon, where each carbon atom is stuck to 3 other carbons, and these layers are just 1 atom thick. These are the thinnest structures in the universe. And graphene, this stuff here, stacks together to form graphite, which is what you use in your pencil. Now, the thing about graphene, why it's important is you can imagine taking a square, or a rectangle, or a square or a rectangle or this funny shaped thing, and depending on how you put them together, so if you stack them on the left you get graphite, or if you roll a rectangle up you get this sort of tube-like thing, or you take this funny shape and you wrap it up in the right way, you can get a ball. Now that was sort of in theory, but people had only ever seen graphite. And then, or a square or a rectangle or this funny shaped thing, and depending on how you put them together, so if you stack them on the left you get graphite, or if you roll a rectangle up you get this sort of tube-like thing, or you take this funny shape and you wrap it up in the right way, you can get a ball. Now that was sort of in theory, but people had only ever seen graphite. And then about 20 years ago, people found that actually they could make these balls, and this is called carbon-60. And this actually, it may seem like just a sort of a little thing, but this won the Nobel Prize in 1986, because this was the first new form of carbon that had been discovered since ancient times. And then in 1991, people found these cylinders of carbon. So that's the second sort of new form. And you can see, you can imagine it just by taking some chicken wire and rolling it up. And the interesting thing is they can be rolled up different ways, and if you roll it up one way, you get a metal, and another way, you get an insulator. These carbon nanotubes can now be grown in these what we call forests. So starting here, going right up to the top, and if you zoom in with a microscope, you can see this black thing is made of all these things growing up vertically, and if you look in even closer, you can see that these are hollow cylinders. And that distance there is 1/1,000,000th of a millimeter. So that's really, really tiny. Now these cylinders are really narrow and really, really long. And they're so long compared to their diameter that if I held one that, say, was this width in my hand and held it like that, the other end would be in Liverpool. So these things are really, really long compared to their diameter. So one thing that people have done is, with a tweezers, you can grab the top of that and pull it. And what will happen is, they all come out. And you pull one, and it pulls the next one, and it pulls the next one, and they pull out as this sheath. And people have taken these sort of sheets and stuck them on top of each other, and this might be 5/1,000,000th of a millimeter thick. And you can also twist them into these fibers, and you can braid them into ropes and all sorts of stuff. Now, the reason that's important is that those fibers, those things there, are really, really conductive, so people have used them to make light bulbs, and these light bulbs last 50,000 times longer than a normal light bulb. They're also really, really strong. This is one of those sort of sheets of carbon nanotubes, and these are droplets of orange juice, grape juice, and water. Now, the reason this is important is that the bit of carbon that droplet is sitting on weighs 50,000 times less than the droplet. So that's like me lying down and having a 5,000-ton weight sitting on top of me. That's not going to have a good outcome. But this stuff is so strong that that's not a problem. Nanotubes are 50 times stronger than steel, and even those fibers are 5 times stronger than steel. And that means that if you made a fiber that was 1 millimeter in diameter, it'd be strong enough to lift a small car. I mean, that is amazingly strong. These things are stronger than any other thing known to man. And this is what we use them for, and this is one thing that we're doing here in Cran, and this is a new slant and old technology. This is a photograph of a mud brick wall in the desert in Israel. And if you look very, very closely, you'll see that there are little pieces of straw in that mud. And people have been doing this for 4,000 years. You can make bricks out of mud only if you add straw to make them a little bit stronger. Nowadays, we're not using straw, but we're adding carbon nanotubes into plastics. And if we do that, we can increase the strength of a plastic by a factor of 4 just by adding 0.5% of carbon nanotubes. Now, that's a very, you mightn't think it, but that's an incredibly important technology. If you can increase the strength by a factor of 4, that means the amount of plastic you need to do a given job can be reduced by a factor of 4. And if you think of all the plastic that's in airplanes or cars or trucks or ships, and if you can reduce that by a factor of 4, the energy that you need to move those things is reduced dramatically, and that means much, much less CO2. So that links in nicely with the previous speaker. And in fact, this sort of stuff is in all sorts of modern technology. And this bike, for example, was in the Tour de France 2 or 3 years ago. This bike frame is made of plastic reinforced with carbon nanotubes, and the frame of that bike weighs 600 grams. That is amazingly light. So that's the link between nanotechnology, these new materials, and modern life. So the real challenging applications are in the future. This is a schematic from NASA, and this is a future spaceship, and they've marked all the places where they think carbon nanotubes will play roles. And they'll be from the batteries that fuel the thing, to the computers to control it, to the ailerons and the wings, everywhere. There will be these future carbon materials everywhere. But probably the most dramatic application is, why do you want spaceships at all? At the moment, we use them to launch satellites, but it takes an awful amount of energy to get a spacecraft up to orbit. What people want to do is, well, why don't we have an elevator going up to orbit? And in fact, it's not as outlandish as you might think. All you need is a rope that's strong enough to support its own weight over a distance of 36,000 kilometers. Now, that's quite a long way. And that means that rope has to be really, really strong. And it turns out there's only one material known to man strong enough to make that rope. Carbon nanotubes. So 50 years' time, maybe. Thank you.